If you have worked with APIs for some time, you have probably already used things like basic auth, API keys, sessions, JWT, OAuth, or maybe OpenID Connect as well. And using these things is actually not that difficult anymore because almost every framework gives us libraries to implement them. The confusing part is understanding where we should use what. When is an API key enough? When should we use session? Why do we need JWT? And if we already have JWT, then what exactly is OAuth doing? So this is what we are going to understand in this video. We will go through major authentication mechanisms that you will actually see while building APIs, understand how they work, and more importantly, where each one fits. And instead of learning them as completely separate concepts, let us see how one naturally leads to another. Let's start with simple one, basic authentication. With basic auth, the client has a username and password. It combines both of them. Base64 encodes that value and sends it as HTTP authorization header. So the request looks something like this. Authorization basic and you have an encoded credentials. The server receives the value, decodes it, checks the username and password, and if they are correct, the request is allowed. This is basically basic auth. But there are two things we need to understand here. First, base64 is not encryption. Anyone who gets that encoded value can decode it very easily. So basic authentication should always be used over HTTPS. Second, the username and password are sent with every request. If I make 10 API calls, I am sending those credentials 10 times. Because of this, basic auth is usually not what we use for modern web user interfaces. You may still see it in internal tools, older APIs, testing environments, or some simple server-to-server integrations. But for most applications, we do not want to keep sending actual username and password again and again. So can we send some other secret instead? That brings us to the API keys. An API key is simply a secret value given to a client. It might look something like this, and the client sends this key whenever it calls the API. For example, this is an API key. The server receives the key, checks whether it is valid, and now it knows which application or customer is making the request. You have probably already used this. OpenAI gives you an API key. Stripe gives you an API key. Google Maps and many other developer APIs work in the similar way. Once the server knows which key made the request, it can do things like track usage, apply rate limits, calculate billing, restrict access, or completely revoke a particular client's access. But there is one important difference between an API key and a user login. An API key normally identifies application or client. It does not necessarily identify the actual human user inside that application. For example, suppose my backend has one OpenAI key and 10,000 users are using my application. When my backend calls OpenAI, OpenAI can identify my application from that key, but the API key itself does not tell OpenAI which one of my 10,000 users clicked that button. So API key are very useful for application to application communication. But now, suppose I am building a normal web application and users need to log in. For that, one very common option is session-based authentication. Let's say the user enters an email and a password. The browser sends those credentials to the server. The server verifies them. Once the credentials are correct, the server creates a session. Internally, it might store something like this. Then the browser gets that session ID, normally inside a cookie. From the next request onwards, the browser automatically sends that cookie. The server reads the session ID, looks it up, and understands this request belongs to user 42. This is session based authentication. And sessions are still a perfectly good way of doing authentication. Sometimes developers learn JWT and think that sessions are old and JWT is the modern replacement. This is not really correct. For many normal web applications, sessions with secure cookies are actually a very good solution. This also gives you a simple control over revocation. If a user logs out, just delete the session. If the account gets compromised, invalidate all active sessions. The trade-off is that the server needs to store this session somewhere. If you have multiple backend servers, they normally need to access the common session storage, maybe Redis or maybe database. Now we get another idea. Instead of keeping authentication state on the server and looking it up every time, can the client give us some token that we can validate? That brings us to the bearer token and JWT. We have probably seen this header many times, authorization bearer. And the first thing to understand is bearer does not mean JWT. Bearer simply tells us how the token is being presented. The value after bearer can be different kinds of tokens. It could be a random string or it could be a JWT. For example, suppose the token is something like this. There is no information you can understand by looking at this. The API may have to look that token up somewhere and ask, is this token valid? Who does this token belong to? What permissions do I have? That kind of token is often called as opaque token. JWT takes a different approach. JWT stands for JSON Web Token. And one thing I want you to remember is JWT is a token format. It is not complete authentication protocol. A JWT can contain claims inside the token itself. For example, it can contain user ID, who issued the token, which API the token is meant for, when the token expires, and maybe roles or scopes. A JWT is also normally signed. So, when the API receives the token, it can verify that the token came from someone it trusts and that claims were not changed. But the signed does not mean encrypted. A normal signed JWT can usually be decoded and read. So never put passwords, API secrets, or sensitive information inside a normal JWT payload. Now let us see why JWT is useful. Suppose we have one authentication service. Then we have one order API and payments API. The authentication service issues a signed JWT. When the user calls orders and the order service can validate the token, when the user calls payments, payment can validate the same token as well. If we use public and private key signing, the authentication server can keep the private key and the other services can use the public key to verify the token. So these services do not necessarily need to call authentication service for every request. But JWT also has a trade-off. Suppose I issue a token that is valid for 1 hour. After 10 minutes, I disable that user's account. The JWT might still be correctly signed. It has not expired. So if the API is only checking the JWT locally, it may continue accepting that token. This is why access tokens are normally short-lived. If we want the user to stay logged in for longer, we can use a refresh token to get another access token. So the simple way to remember this is access token is used to call the API. Refresh token is used to get a new access token. Now we understand what these tokens are. But there is still another question. How does application actually get an access token securely? This brings us to OAuth. Suppose I built an application that needs access to GitHub repositories. One way would be to ask you, give my application your GitHub username and password. Obviously, we do not want to do that. Instead, my application redirects you to GitHub. You authenticate directly with GitHub. Then GitHub shows you something like the application wants permission to read your repositories. You approve it. After that, my application gets an authorization code. That code can be exchanged for an access token. Then my application uses that access token when calling GitHub APIs. So my application gets access to some of your GitHub repositories without knowing your GitHub password. And that access can be limited. Maybe my application can read the repositories, but it cannot delete them. This is the main problem OAuth solves. It gives one application delegated access to another system. Now, there is a very important connection with JWT. OAuth access token can itself be a JWT, or it can be an opaque token. OAuth does not say that every access token must be a JWT. So when someone asks, should we use OAuth or JWT? That question is mixing two different concepts. OAuth defines the authorization flow, how the application gets the access. JWT may be a simple format of the token that is issued during that flow. This is how they fit together. Now, there is one another thing you will be seeing all the time. Sign in with Google, sign in with Microsoft, sign in with GitHub. We loosely call all of this OAuth login. But OAuth itself is mainly about authorization. If we also need standard user identity and authentication, OpenID Connect or OIDC is normally used on the top of OAuth. And this introduces an important distinction. You may now have an access token and an ID token. The access token is meant for calling an API. The ID token gives the client information about the authenticated user. For example, when the user log in, which identity provided authenticated them, their user identifier, or maybe email or some other identity claims. So do not treat access token and ID token as the same thing. If your front end needs to call an API, normally it should send an access token that was issued by that API. ID token has a different purpose. This becomes important when you start working with platforms like Auth0, Okta, ClickLock, Cognitive, or Microsoft Identity Services. There is one more thing we need to understand. Suppose I make this request order/8371 and I send a perfectly valid JWT. The signature is correct, the token has not expired, the server knows exactly who I am. Does that mean I am allowed to see order 8371? Not necessarily. Maybe that order belongs to another user. This is where authentication and authorization are different. Authentication tells us who is making that request. Authorization tells us what is this person allowed to do. So even if your JWT validation is perfect or your OAuth implementation is perfect, your API still be insecure if your authorization checks are wrong. You still need to check things like permissions, roles, scopes, resource ownership, tenant boundaries, and whatever business rules your application has. A valid token does not mean unlimited access. Now, if we put everything together, the decision becomes much easier. If you have a simple internal integration, basic auth over HTTPS can still work. If another backend application is consuming your API, you mainly need to identify that client. An API key may be enough. If you are building a normal first party web application, server side sessions with secure cookies can still be a very good option. If you have multiple APIs, you want them to validate signed claims locally, a JWT can be useful. If another application needs limited access to resources on behalf of a user, OAuth is designed for that. If you also need standardized login user identity on the top of OAuth, this is where OpenID Connect comes in. These are not strict rules. Your actual choice depends on system you are building. But the important thing is to first understand what problem you are solving. If you want to remember only a few things from this video, remember this. Basic auth sends credentials with every request. API keys normally identify applications or clients. Sessions keep the authentication state on the server. Bearer tells us how the token is being presented. JWT is a format for carrying signed claims. OAuth handles delegated authorization. OpenID connects add identity on the top of OAuth. Once you understand what each of this is actually doing, API authentication becomes much easier to reason about. And instead of choosing JWT or OAuth just because everyone else is using it, you can choose the mechanism that actually makes sense for your system. Thanks for watching. If you like this video, please subscribe to my channel.